All right, today we'll finish up with the solar system. So we talked about the universe itself, and much of that discussion was focused around the Big Bang and the creation of the first force of which is gravity, and the first atoms that came into existence according to popular theory, which would be, of course, the helium, hydrogen, helium, and lithium atoms. Then we started talking about planets and how they formed, and we looked at some moons. They're pretty interesting, I think. And today we're going to finish up with our discussion of space with the solar system. Okay, so extrasolar planets are planets that are outside of our solar systems, and they go around other stars. They revolve around other stars, and just like the planets in our solar system, they can be either gaseous or they can be rocky, and some can be like super hot, and some can be super cold. So what you see here in the pictures is a comparison. Oops, I didn't want to do that. A comparison of the sizes of some of these extrasolar planets, planets that are outside of our solar system. And Kepler 20e is one of them. It's a little smaller than Venus. And Kepler 20f is actually a bit bigger than the Earth. And of course, Earth is bigger than Venus. So it just gives you some sense of dimension there, I guess. So you might wonder, well, how do we find other planets? Well, when we have two large objects that orbit each other, neither of them stay still. So if we see a star that has a wobble to it, when we're looking at it through, say, the Hubble telescope, if we see a wobble, we know that something must be going around it. So the bigger the wobble, the bigger the planet. So they basically measure the size of the wobble, and that gives them their best guesstimate as to the size of the planet. So another way that we can find planets is using the transmit method. So basically some planets will block the transmission of light from their star when they go in front of it. So if the planet's revolving around a star, it would be its sun, like we have our sun, which is a star. As it passes in front of it, or between us and its star, it will block a portion of light. So we can see the light get a little dimmer for a little while. Once we watch that planet for a long period of time, and we begin to pick up the pattern of how often it passes in front of that star, we can eventually plot out how long a year is for that star. Because remember, a star is basically the amount of time that it takes, a year is the amount of time that it takes to travel around the planet's star, primary star. So for us, it takes us 365 days to get around the sun. So that's how many days are in 1 year for us. We can also use direct imaging to find planets, just by simply taking a picture of them. We can identify planets. So you can see here that a picture was taken. We find planet B. That would be this lightly colored one over here. And then we have planet C, which is very bright, so it's probably a gaseous planet. And then we have a star here in the middle that you're not seeing any light from, but there's an X there to indicate where it is. So probably some clouds in front of it right now, or massive dust clouds in space there. And then planet D looks to be a gaseous planet as well. So that's really it for that. There's some review going back to the galaxies on your worksheet. So we talked about this yesterday, and we'll go back and look at it for a moment here today. So we have a number of different types of galaxies. We have an elliptical galaxy, has a bright spot at the center. We have a irregular galaxy, and don't forget also that galaxies are made up of stars, planets, and dust. Okay. Gas could be in there too. Alright, so the types of galaxies, you're going to draw pictures of these. You're going to do an elliptical, you're going to do an irregular, a spiral, and a barred spiral. And those are the 4 types of galaxies. Okay, so what 3 things do most stars become? If you recall, I think on the previous page or 2 pages back, you had a kind of a flow chart of the life of a star, or maybe it comes after this. Yeah, so they can either become a white dwarf, a neutron star, or a black hole. What force causes stars to form? That would be, where are they? Gravity, right? These are all of our moons. And then stars are made out of gases. And the exit ticket is the same question, so I guess you're answering that one twice. Okay, and that should finish up the discussion of the universe and everything in it. Now, tomorrow you will be starting on a 2-day project, which actually you have 4 days because you have till Sunday for all of the assignments this week, as usual. But starting tomorrow, you will see, well, hopefully today I'm going to post the project for tomorrow and Friday, which will be to create a travel brochure to entice tourists to visit the planet that you choose to promote. It can be a planet or it can be a moon. Okay? So you can research, even if it's a planet we haven't discussed, you're welcome to use that. You can do some research on Google or go to NASA's website, do some research on planets. But you'll see the assignment hopefully today or first thing tomorrow that will have some resources that you can use to find information about the planet or moon of your choice. And it'll have instructions on all the information that you're supposed to include in your brochure. Okay? All right. If you have any questions, shoot me a Schoology message. Thank you.